let's take a look at this circuit. In a previous video, I solved this one, the top part, and we calculated what the total current was in our previous video. And we found that total current to be, current total was 3.27 amps. In this video, I'd like to talk about parallel circuits, definition of a parallel circuit. And let's have a look at what it says here. Two or more electric components are considered to be in parallel if the same voltage appears across all these components. Excuse me. In a simple parallel circuit, the total current is the sum of all the branch currents. And here are all the branch currents. And that total of all the branch currents needs to add up to the total current right here, which is leaving the battery. Well, let's draw this circuit. It looks like this. And we have three parallel circuits. Each one of these parallel circuits is called a branch. So that's one branch. Here's another branch. And we'll connect it all up here at a node. Where the connections are, these are called nodes. And we'll put another one here. Connect it up. And each one of these resistance has a value. Here they are. And let's write them in. So we got 6 ohms here. And 14 ohms coming down here. And 29 ohms. For visualization, you can consider all of these to be 3 different light bulbs. 3 different light bulbs. And they're all connected in parallel to this voltage source. And the voltage source is 12 volts. And in a series, in a parallel circuit, the voltage is the same across all of the components. Across all the branches, I should say. So 12 volt source here, to be 12 volts coming down this branch, 12 volts down this branch, and 12 in this branch. 12 volts. 12 volts. Whereas in a series circuit, the voltage drops, but in a parallel circuit, it's the same voltage going down each branch. It is the current that changes in a parallel circuit, whereas in a series circuit, the current remains the same. And I said that in a previous video. So what we need to find here are the individual currents coming down each one of these branches. So let's find current 1. We'll call this current 1. We'll call this current 2. And there's current 3. And looking at these individually, that branch, and this branch, we can use Ohm's law for each one of these individually. V equals IR. Rearranging this for current. Current is equal to V divided by R, so we'll call this current 1, current 2, and current 3. Putting in the numbers now to find out what the current is down each one of these branches. Current 1 is the voltage, which is 12 volts, divided by the resistance, 6 ohms. And that is equal to 2.0. And current has the unit of amps. Doing the same thing here. And at I1, I2 is equal to the voltage. So in a parallel circuit, the voltage is the same throughout all the branches. Same as the battery. Divided by 14. And current 3, doing the same thing, 12 volts divided by the resistance, 29 ohms. And current 3 is equal to now let's sum all of these together. Current total is equal to I1 plus I2 plus I3. Adding these together, 2 amps plus 0.8 0.57 amps plus 414 amps. Doing this summation, current total is equal to and this is what we calculated excuse me, in a previous video. That is the amount of current that is being drawn here is 3.27 amps. And as the current travels through the circuit, it is being split such that 0.2 amps go down this branch, and 0.857 amps will go down this branch, and 0.414 will go down this branch. So the current is split among the three branches, whereas the voltage remains the same. And that is a basic definition of a parallel circuit.